Hello, welcome all. This is Prashant Kumar Vemula and I am going to demonstrate the first experiment of digital signal processing laboratory. The first part of it contains the moving average filter and also the derivative filter of the first order difference and also the 3-point central difference. For the simulations, we are going to use the Arduino software and Arduino Duo board. All the Arduino, as you look at the first experiment, it is saying to let's have a look at the formulas whatever used in the experiment. For the moving average filter, we calculate the average of the for every L data sets. Let's move to the code. Now let's look at the float. As you see here, we defined the L has been given a value of n 9. The input signal is taken in the array in the variable x and the output signal is taken in the variable y. Then we computed the filtered output from the main function goes in the void setup. Here, as we see, for every L values, we are calculating the average. The sum is made 0 and for every L values, it is calculating the sum and then it is getting divided by L, which we have given it is an N 9. As we need to do it for every L value for every time, this has been run in the void loop and the loop goes endlessly. If we run the code, we will get the results as shown in the picture, as depicted in this picture. We can observe the plots using the serial plotter, which we have written in the code. The blue colored signal is the original PPC signal and the red colored one is the output, which is the filtered output. If the if the filter length increases, the smoothness of the output increases. So the if we say like if we take higher value of L, it leads to the curve gets more smoothened. Now let's move to the derivative filter. Here we are looking at the first order difference derivative filter, which we have to just calculate the consecutive differences of every consecutive data points. If we calculate, it's just a high pass filter. The difference of the present output and the past input, present input and the past input becomes the output point. It's also known as the backward. It is also known as the backward difference filter. Now let's look into the code. Here we have calculated the difference between the data sets of the I and I minus 1, which is the saying like present and the previous data point. And if we see here, the blue one is the input and the output is colored in the red color. It it allows only high frequency components, but the signal is much more distorted. As we see here, there are more the signal is more distorted. It's not smooth as we have. It's not as smooth. Similarly, for the derivative filter of 3-point central difference also acts as a high pass filter, except the transfer. The only difference is that the transfer function changes. The difference of the present input and the second passed output. Previously we have taken the just previous value, and now we are moving to the x of n minus 2. Here we can see the difference. In the above one it is x of n minus x of n minus 1, and here it is x of n minus x of n minus 2. It is also a backward difference filter, as we are moving to backwards. It is n minus 2, right? This filtered output is also much more distorted. If we run the code, we can see that the signal is also much more distorted. To remove these distortions, first we smoothen the signal using the moving average filter. As we seen here, moving average filter smoothens the curve. The distractions of the input signal are more, but the distortions of the moving average signal are comparatively very less. So to remove the distortions, we will use the moving average filter and then use the derivative filter to get less distorted output. Here the blue colored is the original PP signal, the red colored is the filtered output. It allows only high frequency components. Filter signal is less distorted than the previous one. Here we can see this, it is much less distorted than the previous one. Now let's look at the removal of baseline component. Now let's look at the removal of baseline component of the signal. The PPG data contains the original PPG signal plus baseline drift component and the high frequency noise components. To get only the PPG signal, both the high frequency noise components and the baseline drift components are to be removed. High frequency components can be removed using the moving average filter of length 8. If we further increase the length to about 800, the cutoff frequency of the filter becomes very small, so that it just falls above the baseline component frequency. The original signal is subtracted from this baseline signal to obtain desired output. Now let's look at the code. Here we have taken two different lengths. One is with L is equals to 8 and one is with L2 is equals to 800. Our filter signal after removing high frequency components is stored in variable y. Now the baseline components are removed using filter of length 800 and stored in z. The final filter signal is the difference of y and z. Here we can see now the blue colored is the original signal and the red colored is the red one is the baseline drift. And here it is the final filtered output. So the distortions have been decreased a lot. Thank you for watching the video. I hope you like it.